to a video about the definition of a rational number. So we're looking at rational numbers in this whole playlist, in this particular lesson. I just want to start off by defining what exactly it is. So a rational number, as you can see there, I got the definition. A rational number is any number that can be written as a fraction. That's it. That's what we're talking about when we're talking about with rational numbers. So a lot of times in a textbook or in a class, you may see it defined as any number that can be written as A over B. So A is any real number, B is any real number. As long as I can find a combination of A and B and put them in a fraction, those are real numbers. So let's look at some examples of rational numbers. Let's take a look at the number 50. Let's start with that. 50 would be an example of a whole number, right? If you're learning about your different number sets. So 50 is a whole number. Is 50 a rational number? Well, I can rewrite 50 as 50 divided by 1, right? Any whole number can be written as a fraction. 50 over 1, 50 divided by 1 is 50. Well, there we go. We've just written the number 50 as a fraction. So yes, it does fit the definition of a rational number. Whole numbers are rational numbers. All right, let's take a look at another example here. What about an integer? Let's look at the number -8. Well, we got a negative number here, but it's still 8, and I can still rewrite it as something over 1, right? -8 over 1 is still -8, and since I can rewrite it as a fraction, positive or negative, it doesn't matter, it's still considered a rational number. So yes, it is a rational number. All integers are rational numbers. All whole numbers and all integers are rational numbers. All right, what about, let's get complicated here. What about decimals? What about the number 6.49? Is that a rational number? Well, I can't really write it over 1. I can't use numbers like that and mix fractions and decimals together. But let's think about what the 4 and the 9 represent. So that 4 represents a 4 in the tenths place, right? We actually have a place value name for that. So that 4 is in the tenths place. That 9 is in the hundredths place. Put a little d 100, but then the th is getting into the decimal. So 9 is in the hundredths place. So I could actually rewrite this as 6 and 49 hundredths, or 49 over 100. And if you want to, you can take your decimal, take your calculator, do 49 divided by 100, and it'll equal 0.49. So we just clearly wrote, we know 6, I can take the number 6 and rewrite it as a whole number over 1. So that part's rational. But the part 49 over 100, that decimal part is rational. So yes, 6.49 is a rational number because I can rewrite it as a fraction, 6 and 49 hundredths. Or if I even wanted to get crazy, I could say it's 649 hundredths. So there's 3 examples. Again, whole numbers, integers, and decimals. Again, they have to be terminating decimals. So we'll look, there's a later lesson where I get into in terms of repeating decimals or decimals that have no patterns. But if a decimal stops, if it terminates, such as 6.49, then there's no digits afterwards, we can always write those as fractions as well. And then for a final example, obviously, you could take a big, huge fraction, 637 over 998. And that would be a really complicated fraction, ugly to work with, but yes, that would be a rational number as well. So lots and lots and lots and lots of numbers are rational numbers. Whole numbers, integers, anything that can be written as a fraction. But let's look at some examples. There are some really famous numbers that are not rational numbers. And I want to point some of those out because it's always good to contrast. So examples, here's ones that are not rational numbers. The square root of 2. In fact, there's lots of square roots of numbers that are not rational numbers. If you put it in your calculator, Square root of 2, you get something like 1.41, and you get this decimal that goes on and on and on until your calculator can't handle anymore. But there is no pattern to it. I can't write it as a fraction with a real number at the top, real number at the bottom. So certain square roots, square root of 2, square root of 5, square root of 7, anytime there's that really ugly decimal with no pattern, those are not rational numbers. Another one is the number pi. If you've done any sort of geometry or stuff with circles, you would know that pi is approximately 3.14159, and it goes on and on and on and on and on. It's really famous when we even have a day where we celebrate Pi Day. But pi, although we use it a lot, especially in geometry and circles, it is not a rational number. It's an irrational number. There's no pattern. I can't write it as a fraction. And one other one I got for you is this number called e, which comes up a lot in natural logs. But e is approximately, we're going to put the approximate symbols, 2.718, and it has a decimal that goes on and on. So if you get into logarithms and exponential functions, you'll see this number e pop up. It's kind of a growth function. You see a lot of times in growth patterns. But these are three famous examples of numbers that are not rational numbers. Most of the time in this class, most of the time you're always going to be working with rational numbers. And in fact, in lessons that follow, we're going to review working with rational numbers, positives and negatives, fractions, adding, subtracting, multiplying, dividing, order of operations, just getting really, really comfortable working with rational numbers.